in Swift, like UI kit and everything, they are basically written in Objective-C itself. For example, the UI kit, the UI view controller methods, view lifecycle methods, etc. Both languages have single inheritance, and also both languages have similar design patterns like delegation, singleton, and model view controller to guide the architecture of the app. Also, instead of multiple inheritance, both languages employ protocols to share functionality across unrelated classes. These were the similarities. Now let's come on to the differences between the languages. First of all, and the most important difference is, I would stress this out, that Swift is a statically typed language, which means that the type of every object, every instance is known at the compile time itself. While in Objective-C, it is a combination of static and dynamic typing. The types, and how is it so? The types of the majority objects or instances, you can say, are declared at compile time. Sometimes the type that's declared is ID, where ID means that the data type of this object would be dynamically determined at runtime. And I'll explain this with an example in a short while. Secondly, methods and the objects invoking them are not bound until runtime in Objective-C. You could call a method on an instance of a class, and even if that class doesn't implement that method, your code will still compile. But that doesn't happen in Swift. Swift is a strictly statically typed language, so the method binding or the resolution happens at compile time itself. Because of that static typing feature, Swift is relatively faster because there is no type checking at runtime rather than in comparison to Objective-C. Swift is safer, I would say, than Objective-C because of this static typing and the use of optionals and optional chaining, which this concept does not exist in Objective-C. And to use any object that can have nil value at any point of the time, the object must be declared as an optional in Swift, while in Objective-C, there is no concept of optionals. Any object can be nil at any time. In Swift, the code wouldn't even compile if you try to call a method on a nil object. We all know that. But Objective-C handles nil values in an entirely different way. You can invoke a method on a nil object with relatively, less consequences. There would be no nil pointer exception. There will be no crashes if you call a method on a nil object. That means, keep in mind, that means that you have to relatively keep checking for nil values all across your code, because obviously you don't want to achieve a functionality on calling a method on an object that does not exist. Now mutability is also handled differently in both the languages. In Objective-C, mutability is limited by certain classes and property attributes. By default, all objects are immutable. For example, if you declare a string in Objective-C, you give the data type as NS string. That is not mutable. You cannot change the content once the string has been declared. If you want a mutable string, then you'll have to declare the data type as NS mutable string. That is the class provided by Objective-C interface. In Swift, constants are constants, variables vary, and by default, we are obviously encouraged to favor constants than variables. Now, in terms of value types and reference types, Objective-C encourages reference types like classes over value types. Class is the principal mechanism to bundle data and functionality in Objective-C, while we all know Swift favors structs than classes. Now, we all know that in Swift, whenever we generate a class, whenever we have to create a class, there is only one single file that is being generated or recreated by the compiler. But in Objective-C, every class is associated with two files. One is a header file, which is denoted with an extension .h, and another is an implementation file that is denoted with .m. The header file represents the public interface, while the implementation file hold method implementations as well as any properties that you would like to be private. So whenever you want to expose any properties and methods to other classes in the project, you would declare them in the interface file that is .h. So these are the differences. Now to explain dynamic typing with example, I'll first share my screen.
You're giving you trouble, Shruti?
Are you able to see my screen?
Yes.
Okay. So we'll come on to the structure of the files and everything later on. First, let me explain you how is dynamic typing working in Objective-C. Okay. So here what I declare, this is the first example. Here what I declare is an array. This is a heterogeneous collection of objects. In Objective-C, the arrays are not typed. So what it means is that every object that you insert in an array is basically treated as an ID. So here there is a string, a decimal number, and a date. Now every time I fetch a random number, and from that random index I fetch an object from the array and check out the class type of that array. The point, class type of that object. So the point to be noted here is that I don't know the data type of the object at compile time because it has been declared as ID. So whenever I'll run this code at runtime only, I'll come to know which object has been fetched, whether it is a string, a decimal number, or a date. So let's run this program. The random object that has been fetched from this project, from this code, is a string. So thus the name of the class that is printed is, the data type is string. Now if I run it again, let's see what the random integer has been. This time also again it's string. This time the object that has been fetched is date. So at compile time I didn't know what would be the item. At runtime I come to know that the data type of that item is date. So this was dynamic typing. Now let's come on to what is dynamic resolution. That I told you before that the object and the method are not coupled until the runtime. So here I create three objects basically, classes student, wizard, and employee. I add them in an array, and then again I fetch a random integer. From that random index I fetch a random object. Now the thing to be noted here is welcome message is a method that has been declared in all the three classes. Let me show you. So this is the welcome message, and the implementation varies about the behavior obviously is different according to the class. The welcome message implementation in student is different, in employee it's different, and in wizard it is different. So again, since the object is declared as ID, I don't know which object would be fetched and on which version of welcome message would be invoked, I should say. So this is also determined at runtime which object would be fetched, and again, which version of welcome message would be invoked. So let's run it again. This time, the object that has been fetched is an employee. Thus, and the welcome message of employee object is invoked, and it says, "Hi, my name is so and so." Because in employee, this was the implementation of the welcome message. This time, the object that has been fetched is a wizard, and the implementation is different as depending upon the data type of the object. So this is dynamic resolution in Objective-C. Now, let's say I have another array, and again it contains student, employee, but this time I replaced an object with a simple string string instance. Now I know that no welcome message method is presented in the string object. So this time whenever I run since the object that was fetched using the random index is string, and string does not contain any welcome message. So runtime exception is thrown, which says that unrecognized selector sent to instance. So this was, a kind of risky behavior while using dynamic typing in Objective-C. So a fix to use the dynamic typing flexibility in Objective-C was we always used to declare we always used to, type check the object before using the response to selector method. And if the the method was available in the objects class implementation, it would work. Otherwise, it would bypass. So this is a dynamic resolution. Now let's come on to the structure of the files. Hmm. So this is a sample app that I created in Swift, and the same app I'll show you in Objective-C, and how both of them, vary. So this is just a simple task list, displaying the task list of a task list. If I, change the task from here, it will be changed in the task list. As we know, it is very simple in Swift, just a simple array, table view data source, table view delegate, and detail view controller protocol, to pass the updated data back to the parent view controller, from which the view controller has been invoked. So this is Swift. Now let's check the implementation for the same app in Objective-C. It's so difficult in using Zoom. In Objective-C, the main entry point of the application is main.m. So whenever the project launches, first the control is received in .m, in main.m, and then on to the app delegate and everything. As I told you before, that in Objective-C, for every class, two files are generated, .h and .m. So here again, when I created view controller, so this is the interface file and this is the implementation file. Interface, we every time we keep those methods, declarations, and properties that we want to be, exposed to other classes, but I didn't want anything, so I kept everything in implementation file. So to declare a property in an Objective-C, first you use the keyword @property, then the attributes identifiers, and then the name of the data type and the instance variable. In Objective-C, every statement has to be, end with a semicolon. So that is why there is a semicolon over here. Now for implementation, what is the method signature? First of all, there is a hyphen, then the return type of the method in parentheses, and then the name of the method. This is the method signature. Now, whenever you want to call a method, there is a square brackets, the instance on which the method you want to be invoked, and then the name of the method. Again, this is the instance variable table data array. So here there is no concept of let or var. You have to explicitly describe the data type. So since I want my array to be mutable, I use it as an ns mutable array, and I add objects here. This is the method signature to write objects. There is a method on ns mutable array, which is array with objects, and you pass in each and every object. As for Objective-C, there is a convention that when you want to, delimit, you want to tell the that this is the end of my array, you give it a nil at the end of the array declaration. So this is the data source. As you can see, the name of the methods are relatively like in Swift only. This is the number of rows in section, self or row at end path. The difference here is just that the method signature is different. Here you explicitly start with a return type, then the method signature. In parentheses, you give the data type of the instance variable, and so on. This is again self or row at index path doing the same thing. Now, as I told you, that there is also in Objective-C also we use protocols like in Swift. So in detail view controller, whenever I updated a task, I have to send the data back to the main view controller. So I created a protocol for that. I created a protocol for that, give the protocol the required methods that need to be invoked, used, and on done button pressed, I call the protocol method on the delegate object. The method signature is the same, square brackets, semicolon, initially the name of the object, and then the method name. And here is the protocol implementation. The the task is being, the table data array is being updated as per the input, and thus I reload the table views depending upon the updated data. Mm, storyboard and everything is same. There is no difference in Swift or Objective-C, obviously. And yeah, if you want to, that was the UI kit classes. If you want to declare a different type of class, I mean, just a class or a data holder kind of thing. This is, for example, for student, I created a student object. These are the names of the properties, class names, subjects. And because I wanted you to be used in another classes, they are declared in interface file, and in implementation file, I implement the implementation of welcome message. I think that would be all from my side. Jeff?
Shruti,
Uh,
I have a
Yeah,
question.
yeah.
Uh, there was a place where in front of table view you had used an underscore. So does that carry any meaning over there?
Where? Okay,
Uh,
yeah.
at the bottom.
So these are basically the, in Objective-C, you have a concept of auto-synthesized properties. So since I declared a property with name table view, the compiler would generate a auto-synthesized property, and that can be used with using, underscore in front of the property name. So this is the auto-synthesized property concept, if that
Thank
makes
you.
sense.
Ooh, that was really awesome, Shruti. Thank you.
Thank you. I'll stop sharing.
We can give a round of applause for Shruti for, she obviously spent a lot of time preparing that.
Thank
That was
you.
really, really well done. So I'm trying to think, I wrote down a couple of things because I wanted to try to add to it, but you actually did like an awesome job, and I think covered most of what I would have. I will do my go-to and share the screen, or share my screen real quick and show you the iOS dev community survey, just to sort of give some context where Objective-C is compared to Swift UI at this point. All right. So yeah, I was slightly surprised, honestly, by this. Well, not really that surprised, but I hadn't looked at this data in a while. So again, I mean, there's some, you have to take these results with a little bit of a grain of salt because it's a somewhat small sample size, and it's, not like a random sample of all iOS developers in the world or anything. But you can see here that, like, okay, what's the balance of Swift to Objective-C code that you've written for your personal Apple platform projects in the last 12 months? And you can see 70% are 100% Swift. So that tells you, 30%, or basically like everybody's doing a little bit of Swift, or a lot of people are doing a little bit of Swift. A few are doing purely Swift, but very, very few in their personal projects, which to me isn't that as useful a data point as your businesses. So here it's it's lower, right? This is because same kind of reasons that I mentioned. We're not trying to jump on Swift UI right away. That usually businesses trail about two releases, two major releases behind, depending on the type of application. And so new things don't necessarily exist right away. And then on top of that, there's a lot of expenses associated with, like, hey, if I have a working app, like, well, you need to convince me why I want to spend whatever hundreds of thousands or millions of dollars to get certain modules rewritten in Swift. So that kind of thing takes time, right? And Swift is still relatively new, so there's still some Objective-C code out there. There's actually less pure Objective-C projects than I was expecting, to be honest. But I think it's really accelerated in the last, 2 or 3 years, to where pretty much all new development is done in Swift for most places. But you can see definitely there's more Objective-C that you're going to encounter in if you were to just get a job, especially at like a bigger company, right? And probably somewhere that's not specifically a software company, where they might be more apt to just refactor or do rewrites routine basis. Balance of Objective-C code that you've written for your business app. Okay. Actually, what was that first one? Balance of Swift to Objective-C code you've written for your business app in the past 12 months. This is just filtered by company sizes. I won't go into all of those boring details, but I guess the point is, people are still using Objective-C, but I think if you were to look through job postings, you might occasionally see some reference to Objective-C experience being desired, but the vast majority are going to be looking for Swift developers. I'll tell you a little bit, like, from my personal experience. I'd say, and I can't go into, I don't want to go into like much detail on like the current employer, but the prior employer, when I started there, and that was probably, it was like right when Swift was announced. That's what, 6 years ago, I think. Starting to really lose track of time these days. But it obviously was all Objective-C at the time, and we very slowly, I think like probably about 2 years after Swift, maybe 2.5 years after it was out there, we started writing some new things in Swift, just to sort of test the waters. And I'm pretty sure today they're doing like everything new in Swift at that place. Because kind of when I left, that was the course we were heading towards. And at bigger companies, I think you're definitely going to see like there's going to be like old infrastructure type libraries that are maintained that probably it's harder to sell the idea of like, hey, we need to rewrite all this code that is interfacing with some old system, or there's billions of examples of different types of things, and none of them are coming to my mind right now that aren't too specific. So but that being said, there definitely is going to be old Objective-C code out there still for a while, and probably for a very long time at certain companies. And there are some things I think where Objective-C, like there are some people that prefer it. Like one of the things I missed the most about it was that compile times were like so fast compared to Swift. So like on a non-trivial, like, when you're working on like a tutorial or a small app for homework, it's not particularly painful. But if you're building, a big application that's, got a lot of functionality in it, it can take like, geez, what I think I read, was it about Facebook? And I can't remember, but one of the bigger companies, I know people were talking about the compile times on their builds being like, I think about an hour. I haven't seen anything that bad in my career, but that's you know, there can be some long compiling Swift code, and then I'll say like occasionally when I go back to Objective C and things just compile like that, and even like very old things still compile for me. It's a little bit of a, you know, a little bit of nostalgia kicks in. But for me personally, like the vast majority, like everything new I write is in Swift or maybe even Swift UI now, and I do encounter Objective C that I need to debug here and there, and maybe I'll have to make some minor tweaks to some old Objective C code some days, but it's definitely not something unless you're going for a very particular type of job. It's not something that you really need to learn much more than you know, getting that overview from Shruti. But I think would be a good start, so you can at least like see it and not freak out that it's how weird it looks and what's this .h file. So anyway, that's just sort of my 2 cents about that topic. But thanks again, Shruti, for that awesome presentation. And if you don't mind, I did remember to start recording that like when you're about 2 sentences in, and I don't know if you don't mind, I can share it so folks can watch it later. Just
Yeah,
like
sure,
within the
no
track.
problem.
Okay.
No problem.
So I think I guess we're out of time. But if anybody has any other last minute questions, I've got a few minutes.
Yeah, I have a question. If Apple hadn't switched to Swift, do you think that iOS application development would still be this much famous or popular?
I think it would, because basically what drives at the end of the day, what drives people to develop for the platform is that there are people paying money for, you know, paying money for these applications, or the, you know, basically the iPhone is going to be prevalent regardless of what the applications are written in and how painful it is for the developers. And if you're like a big company, you have to have an app that supports the iPhone, right? So um, I think it might have hurt a little bit, like maybe some talent would have leaked over, like when Kotlin shows up for Android, you know, and it would start to potentially lag behind in terms of you know, speed to market and maybe quality level of applications. But Objective C is still you know, it's, I think they actually honestly still are you know, tweaking it. And it's alive and well, so it's totally viable. Like you could write anything in Objective C today. So I really don't think that's a tough question, but yeah, if I had to guess, it wouldn't have made a huge difference to kind of the industry.
I would like to add something here.
Mhm.
So actually, you know, the thing is, as long as there is nothing to compare an item or an object with, there is no concept of the demand or everything. Because while I was developing apps in Objective C, that was the only language, and we used to love exploring it or, you know, writing in that syntax. But as Swift arrived, then there was a point of comparison: is Swift better or Objective C better?
Yep, definitely true. So yeah, I mean, people will go where the money is, and it really wasn't that bad. You know, there definitely were some things that were fun about it. Like I said, it built faster. Honestly, it was a little less. It didn't hold your hand as much, so you could do some cool stuff with it, frankly, and it made it less safe and less readable. But if you were like in the zone and cranking out some code, like you could write some fun stuff in Objective C. So it's, yeah, it's an interesting question though. I don't know for sure, but I definitely think Apple would be doing okay at least.
Thanks, guys.